Okay, guys, parallel and perpendicular lines. So we're going to establish what these are first. I'm going to jump to the end of the section and then give you the main ingredients, the main stuff about it, and then we'll come back and review it and talk about it, okay? So parallel and perpendicular lines. Write an equation of the line that passes through a given point parallel to a given line. So we'll work on that today. And then write an equation of the line that passes through a given point perpendicular to a given line. First off, let's establish what in the world is parallel. Do y'all know what parallel is? Y'all know what perpendicular is? They never we'll go with we keep it real simple, okay? When you get to geometry with me, they're on the same plane, and there's a lot of different, there's not a lot of different things, but there's like several things they gotta meet. But in this situation, this is what parallel lines are. Like, they never touch, like Christopher said, but we're gonna go with two non-vertical lines are parallel if they have the same slope. Okay? They never touch. You see how this line like this, and this line here? Now, I'm going to show you the slope, guys. I want to pick this point here if you don't mind. I want to go to rise. Remember, the rise is 2. Run would be 1, 2, 3, 4, 5, 6. Negative 6 would be a negative 1/3, right? Look at the slope of this one right here. 1, 2. 1, 2, 3, 4, 5, negative 6. So negative 1/3. You see how they have the same slope? So what happens? By definition, they're parallel. Okay? That's parallel. This is a symbol too, guys. You see this right here, like I guess like an 11. Basically, it's just two lines like that. That means that line AB is parallel to line CD. Now, look at this one over here. Don't write anything yet. I'm asking you to write this down, okay? Two non-vertical lines, okay, are perpendicular if the product of the slopes is a negative 1. So we're going to come back. I want to explain to you right now what this is getting at. I'll show you in a little bit. But let's look at this one real quick. Let's get the slopes. If you don't mind, I'll go with this line right here, EF. I want to do my rise. Pay attention to this one, my rise and my run for E to F. 1, 2, 3, 4, 5, 6. So that's going to be a rise of 6. A run of 1, 2, 3, negative 3. That gives me as a negative 2. Do you agree? Let me get lost there. Now I'm going to do my slope of the other one, of this line here. Alrighty? I'm going to do, if you don't mind, I'm going to just go, I like to go up and to the right, or up and to the left. Doesn't matter. I just like to go up. 1, 2, 3. A rise of 3. A run of 1, 2, 3, 4, 5, 6. Okay, look at these. Look at these. It always happens like this. This slope is now a what? 1/2. Now, remember what the rule says here. Two non-vertical lines are perpendicular. Perpendicular means where they cross at a right angle. I forgot to cover that. At a right angle. You see there's a right angle there. If the product means to multiply their slopes. Okay? So if I multiply these two numbers here, if I come out here and go with a negative 2 times a 1/2, it's supposed to give me a negative 1, right? But let's see what this gives me here. Over 1, right? Negative 2 times that gives me a negative 2. 1 times 2 gives me a 2, which gives me a negative 1. So that right there, you see that? It satisfies this. So these lines are perpendicular to each other. So let's start off with this again. Copy this down. Visually, these are parallel because they have like the same slant, the same slope to them. These are perpendicular because they cross at 90 degrees. But we're going to get more into it right now. Copy these two things down, guys. Please copy those two down. How do we feel, guys? Y'all ready to move on? Make sure you write the symbols. This is perpendicular. This is, my gosh, I'm sorry, that's parallel. That's perpendicular. Parallel, perpendicular. Okay, I'm going to move on, guys. Ready? Okay, here we go. Third. Parallel lines, guys. Lines in the same plane that do not intersect are called parallel lines, okay? They have to be in the same plane. Non-vertical parallel lines have the same slope. Okay, so right here, vertical lines are parallel. Non-vertical lines have the same slope. Okay, so vertical lines. Do you remember what's the slope of vertical lines? Do you remember what the slope is of vertical lines? Anybody remember the slope of vertical lines? What it looks like? 1. Okay, somebody says 1. But let's go back to Mr. Slope, okay? This is the vertical line right here. For it to be like this, it basically says it's what? Undefined. Okay, so vertical lines have undefined slope. So they're still equal to each other, right? But they're both undefined. You can't say they're both equal to each other. Well, we can't even say what they are. But they're both undefined, so they're going to be the same undefinedness. Okay, so regarding this one, say this one has a slope of 2. Well, guess what this one has? A slope of 2. You can write an equation of a line parallel to a given line if you know a point on the line and an equation of a given line. First, find the slope. Okay, first thing you need to find the slope because you want them to be parallel, so they have to have the same slope of the given line. Then substitute the point provided for and the slope from the given line into the point slope form. Okay, so basically it's saying this. If you have a line like this and you want another line going through another point, well, you need another point and you need another slope. First, give me the slope here, and you want it to go to this point, well, then I can get the slope here and make that same slope here through that point, slash I can get my equations of my line through there. And that's it. Really simple. Okay, so write an equation in slope-intercept form for the line that passes through and parallel to this one. So there I have the two things I need. I have my slope, and I have my point. So all we're going to do is use that idea, use that for our advantage. We have my point and my slope. So guess which form I would use? I would use point-slope form, right? And here it is, point-slope form. Plug in my slope of a 2. My point here, remember it's y minus y1, so this is the y, x, right here. Now, I want you to hear this much. It does not say to write the equation, it does say, sorry about that, write the slope-intercept form. So it doesn't say, okay, my bad. It does say to write in that form, so we're going to use this one here and then solve for y, and then we'll get that equation. And that's it. It's pretty easy. It's not too hard. I don't think it's a hard idea. For it to be parallel, same slope. Get the slope from this, whatever they give you here. Get that point-slope form, and then solve it down for y, so it can be in slope-intercept form. Looking at this madness, I'm letting y'all look at it and take it in. Do you have any questions? Okay, let's move up. Let's practice one on our own. Ready? On our own / together. How about that? We'll do that. Okay, write an equation in point-slope form, remember that, for the line that passes through this and parallel to the x-axis. Write that down, guys. Shoot, write that down. Okay, here we go. Ready? It says again, parallel to the x-axis. So let's come in here and figure out what's my slope. Y'all know what's your slope in this situation. Remember, it says you need to know two things: your slope and the point. That's all you need. What is my slope, guys? Does anybody know my slope in the x-axis? What? Does anybody remember the slope for the x-axis? Anybody know it? Anybody know how to figure it out? I'm looking at the chat, guys. Come on. We got to hurry up. We got to wake up here. Okay, so the x-axis, I'm going to show you real quick. It's like this, right? It's this one here? Oh, okay. So let me think. Let me go back to Mr. Slope. Positive, negative, undefined, 0. So my slope here for the x-axis, you see that? It's like this. It's going to be equal to 0. And they want us to write it in point-slope form. Point-slope form, if you remember the formula for that one, is going to be y minus y1 is equal to mx minus x1. Here's my x1, here's my y1. And plug it in and we're ready to go. Y minus y1 is negative 1 equals to m. My slope of m, I'm going to get it from over here, 0. And then we'll go to x minus x1, x minus 4. And there she goes. This is kind of right, but wrong. You see this part here? We're not going to write that like that. We're going to leave it as y plus 1 is equal to 0, x minus 4. And there is my final answer. What y'all think about that, guys? Easy, hard, medium, so-so? Talk to me. Can somebody say anything today? Something say so? Okay, let's practice another one because that's actually it. We're done with our examples. Let's practice another one, okay? Let's try number 7 real quick. Oh, this one's going to be perpendicular. Let's go to one that's parallel, yeah? Let's try parallel. Okay, let's try number 1. Let's try parallelness. Okay, so let's write an equation in slope-intercept form for the line that passes through the given point. This is my given point, and parallel to the graph, okay, of this one. We want it parallel. So help me out, guys, in the chat. What does parallel mean as far as your slopes? What do your slopes have to be if they're parallel? The same. Thank you so much, Dominic. Appreciate it, brother. So let's identify my slope, right? The slopes have to be the same. So what's my slope for this one right here? Anybody see your slope? What's my slope, guys? Come on. 1/2. Perfect. Now, Leilani, no x, okay? It's just half. So we're going to come out here. Now, it doesn't, oh yeah, it does say slope-intercept form. Remember, slope-intercept form is going to be y equals mx plus b. But I have a point and the slope. So I'm going to use point-slope form. Remember, point-slope form is y minus y1 is equal to x times x minus x, oh wait, m, x minus x1. And there it is, plugging my values there. So I'm going to have y minus a 2 is equal to an m of a half. X minus x1, where's x minus x? X minus x1, a negative 1. So we're going to have y minus 2 is equal to 1 half, and then x plus 1. Now, they don't want it in point-slope form. They want it in slope-intercept form. So I need to go out here and do what? Does anybody know what to do here? They don't want it like this. They want it as y equals to mx plus b. They want this. What do I do here, guys? Come on. I'm not. Okay, that'd be, I'm going to do that first. I want to, yes. What am I doing? Tell me in words. What would I do? I guess the big picture. What's the big picture? What's the main idea? What's the main thing I want to do? Okay, if you don't know right now, that's fine. It was a long vacation. I want to solve for y. I want to isolate the y. Okay? And I would do that by distributing first. Christopher, good job. So right here, I would have y minus 2 is equal to 1 half x. Multiply this times this, plus a 1 half. Okay. Now what do I do? I'm almost there, right? Can you see what I'm almost done? I'm almost there. I'm always getting my y by itself. What do I do now? Anybody know what to do next? Remember, I want it to be y equals mx plus b, so I want the y by itself. So I'm going to basically come out here and add 2. Thank you so much, Tristan. And I'll add 2 over here. These will cancel out. I'm going to go with y is equal to 1 half x. If you don't mind, I'm just going to leave it like that. 2 and a half. What do y'all think about that one, guys? What do y'all think? Not too bad, right? Was it difficult? Do y'all want to practice one more, or do you want to move on to the perpendicular? We're good? All right, let's move on. I think I like that. Let's move on. So let me go back over here. Okay, we did that one already. Let's come over here now. Now, perpendicular lines, guys. Lines that intersect at right angles. So you better associate these things. Understand these two things forever now. Perpendicular, right angles. So if I say these two lines are perpendicular, that means they meet at right angles. Okay, there are right angles there. If I have two lines like this, and I know they meet at a right angle, then that means they're perpendicular. You got it? You see what I'm saying, guys? If I say this building, just humor me, this is a building, okay? These are like, it's a building. How are these buildings built to the ground? Oh, sir, they're built with right angles. Oh, they're built perpendicular to the ground, right? Yes. So you got to kind of go with that. Now, perpendicular right angles mean the same thing. So lines that intersect at right angles are called perpendicular lines. The slopes of non-vertical perpendicular lines are opposite reciprocals. That is, if the slope of a line is 4, so this, imagine this is going to be 4. The slope of the line perpendicular to it is a negative 1/4. Okay. See that one? Okay. Negative 1/4. There it is. Now, I want you to look at this real quick. This is opposite reciprocals right here. If I have A over B, reciprocal means to flip it over. Okay? A over B, now it's B over A. Opposite means if it's positive, now it's negative. But just FYI, if it was a negative, A over B, you'd still flip it over, right? And the opposite of a negative would be a positive. See that? So this still happens either way you look at it. So very important, write this down. Write this down, guys. Write this down. Please write that down. You need to know this for sure. You need it. Oh, opposite reciprocals. Oh, opposite reciprocals. And that's it. Okay, how do you feel, guys? Okay? So make sure you write this down. Make sure you know perpendicular lines means right angles. And now make sure you know that the slopes, okay, the slopes of the lines that are perpendicular are opposite reciprocals. And what that means is that if I have one here, 4, for it to be perpendicular to it, another line to be perpendicular to it, it has to have the slope of the negative reciprocal. Well, sir, how are they getting a negative 4 over 1? No, I'm sorry, negative 1 over 4. Well, think about this one. Isn't this really 4 over 1? You see, that would be like my A and my B. Flip it over, right? Well, you see how that 1 would be my B up here now? See that? And my A, or the 4, would be down here on the bottom. So it's true. This one's positive, this one's negative. It does. It works like that. Okay? So you got to kind of think about that now. Remember that forever and ever. Now to check, guys, to check if they're perpendicular, the product, what does that mean? To multiply. You get the slopes and you multiply them. Well, let me get that 4. 4 times a negative 1/4. Let's think about this one. Are they equal to a negative 1? Well, let me multiply this fraction times this fraction. What do you mean fraction? Well, this is really 4 over 1, right? Multiply 4 times a negative 1. Okay, negative 4. 1 times 4, positive 4. Well, is that a negative 1? Yes, it is. Pretty cool or what? What do you all say? Thank God I'm back from Thanksgiving break. I get to learn all this cool stuff. Anybody agree with me? Is that super cool? You get to learn cool stuff. Hey, Zach, thank you for joining us, brother. Thank you for commenting. So let's look at this one, guys. Ready? I'm just going to do this one real quick and then move on. Okay. The outline of a logo, it's a lot of words. That's why I'm going to kind of just go through it real fast. Okay? I'm just going to give you the first example, and that's it. Is DFE a right angle in the logo? Again, DFE. This is how you go first, second, third. Where's D? Here. F, E. Okay? I guess I should change color. Is it a right angle? What does that mean, guys, for me to right angle? Does anybody remember what right angle means? What should you automatically think of when you see right angle or hear right angle? Anybody know what they should be thinking of? Perpendicular. So this one's asking, are they perpendicular? Well, if you look at DFE, you see this line here? It uses those two lines, that line and that line. So basically, we need to figure out if their slopes are negative reciprocals. So I'm going to look at this line right here. I'm going to figure out my slope from here to here. I'm going to go 1, 2, 3, 4, 5. That's a 5. And I'll run 1, 2 over 2. Did you all see what I'm doing here? I'm trying to figure out if they're perpendicular. So I'm going to get the lines. I'm going to get the slopes. I'm going to get the slopes, and I'm going to observe. Remember, if it was A over B, then I'm going to have what? B over A negative. Okay? Now, that, if I can see that, I can see that they're opposite reciprocals. They're opposite reciprocals, man, they're perpendicular. If I want to check it, then I'll just multiply them. Here we go. I'm checking the slope of this line here, and then this line here. That's what I'm doing right now. So I'm going to do that again. I'm figuring out the slopes because they want to know, is this angle here, DFE, a right angle? Is it a right angle here? That's the thing. It's in question. Is it? So I find my slope. 1, 2, 3, 4, 5. 1, 2, 5 over 2. Now I'm going to do the other line right here, okay? I already figured out that slope. Now I'm going to figure out this slope for this point here to here. I'm going to go up 1, 2. 1, 2, 3, 4, 5. Oh, wait. I'm going to go up 2. And I went to the left 5. Wait. Are those negative reciprocals? 5 over 2? Oh, yeah. I flipped them over 5 or 2 over 5. One's positive, one's negative. Now double check if they're equal to a negative 1. Okay, how I'll do that is I'll just multiply them. 5 over 2 times a negative 2 over 5. 5 times 2 is 10, right? Positive times negative, negative. 2 times 5, 10. Wait, is that a negative 1? And guess what I know? They are perpendicular. They are forming a right angle. I don't know, guys. That's pretty cool. And guess what else? Time is up. I did not realize we were going so fast. Guys, I'm going to put this on YouTube real quick. Have fun. Be safe. God bless. We'll see you mañana.